I have seen a great deal of news talking about nuclear fusion and its use as an energy source. What is nuclear fusion? In contrast to nuclear fusion is the process by which two light nuclei combine or fuse to form a larger, more stable nucleus. And because the larger nucleus is more stable, there is the release of an appreciable amount of energy. Nuclear fusion occurs constantly in the sun, and the energy released in the nuclear fusion is what keeps life on Earth going. The energy we receive from the sun as light is what keeps life on Earth going, but that is for another video. The sun is made up mostly of various variants or isotopes of hydrogen and helium. Several fusion reactions are believed to take place in sun's core. For simplicity in this video, I'm just showing one reaction where two variants of hydrogen fuse to form helium. Why is nuclear fusion relevant and why should we know about nuclear fusion? So the thing about nuclear fusion is that it's a cleaner source of energy when compared to nuclear fission, in the sense that produces less radioactive waste. And because of that, nuclear fusion looks like a very promising energy source, at least on paper. Although thermal pollution would be a problem, and that is because fusion needs an extremely high temperature to occur. So in the sun, fusion can occur at 15 million degrees Celsius because gravity helps to bring protons together. On Earth, in a laboratory, the gravity will not be nearly as high as it is in the sun. So to achieve fusion, we have to use a much higher temperature in the range of about 100 million degrees Celsius. At this temperature, molecules cannot exist and most or all the atoms are stripped of their electrons. And at this very high temperature, the matter is in a state called plasma. Plasma is a gaseous mixture of positive ions and electrons. So the problem with nuclear fusion is to reach 100 million degrees Celsius. What solid container can exist at such temperatures? Basically, the answer is none. No solid container can exist at 100 million degrees Celsius. Unless the amount of plasma is very small, but then, the solid surface would immediately cool the sample and quench the fusion reaction. Currently, one approach to solve this problem is to use magnetic confinement, and that may work because all the particles in a plasma are charged particles, and the magnetic field can exert force on those particles and keep them close enough so that fusion may occur.